Today we're talking about Chapter 10, Lesson 7. Our objective is you will find the area of complex shapes composed of polygons by separating the figure into polygons. So looking at our central question, it says, how can you find the area of composite figures? So just a reminder, a composite figure is made up of two or more simpler figures, such as triangles and quadrilaterals. So we're going to break this shape down here and unlock the problem into a couple different shapes. So we're going to break it into the rectangles here, and then we have triangles here, and then we also have the square here. So there's three different kinds of shapes. So looking at this unlock the problem, it says the new entryway to the fun house, or the new entryway to the fun house at Happy World Amusement Park is made from the shapes shown in the diagram. It will be painted bright green. Juanita needs to know the area of the entryway to determine how much paint she will buy. So what is the area of the entryway? Okay, so we're going to break this into a couple different steps. So step one is to find the area of the rectangles. And remember, when we are solving area problems, we need to make sure that we are always writing the formulas so that we know exactly what we're plugging things into and we don't get lost. So the area of the formula, or the area of the rectangular formula, would be A equals L times W. So that is the same thing as area equals length times width. So looking at our rectangles here, it says to substitute the values for L and W and evaluate. So area, we don't know, equals length, which is 10, times width, which is 4. So those are right here. So 10 times 4. And 10 times 4 is 40. And so that would be for one. So to find it for the other one, we would take that 40 times 2, or 2 times 40, which gives us 80 feet squared. Okay. And then our next shape that we're going to look at would be the triangles. So write the formula and find the area of a triangle. Area equals 1/2 the base times the height. Substitute the values for B and H and evaluate. So A equals 1/2. The base of that triangle is going to be 4 right here, because that's what we have down here, and that rectangle is going to have the same on each side. So the base of those triangles will be 4 times the height, which is also 4 because that's given to us right here. It kind of shows us how high that goes. So 1/2 times 4 times 4. Well, 1/2 times 4 is going to be the same thing as 4 divided by 2, which is 2. So then we have, so if we do that first, then we have 2. 2 times 4 would equal 8. So that gives us the area of one triangle is 8, and the area of the other is 8. And that would be feet squared. So then we have 2 times 8, because we have both of those triangles with an area of 8. So 2 times 8 is 16 feet squared. Then step 3 is find the area of the square. Area for, or the formula for a square is area equals sides squared. And then the sides of that triangle, or that square, are 4 each, so 4 feet. So area equals 4 squared, which is the same thing as 4 times 4. And 4 times 4 equals 16 feet squared. Okay, so that's all the steps that we need to do before we actually find the total area. Which I'm going to have to close out to scroll down. Okay, so we had said that so far we knew the area of the rectangles was 80. We knew the area of the triangles was 16 for both of those, and the area of the square was 16 for that one square. So then now what we do for step 4 is to find the total area of the composite figure. We just add all those areas up because that's what would make that surface area. So we add the areas. So the area of the rectangles was 80, which they have already in there for us, plus 16 because that's what the triangles were, and then the area of the square was 16. So if you take 80 plus 16 plus 16, we'll do that up here. 6 plus 6 is 12. Carry our 10. So then 8 plus 1 is 9. Plus 1 is 10. Plus 1 is 11. So 112 feet squared. I'm sure you're going to have to write it over here in the corner. I can't really fit it in there. 112 feet squared. So Juanita needs to buy enough paint to cover 112 feet squared. Okay, looking at example 1 on page 572, it says find the area of the composite figure shown. So what we're going to do is we're going to look at those shapes that we have in that composite figure, so you can break it up. And we can break that into, here we have a triangle, and here we have a square, and then here we have, that didn't change, here we have a trapezoid. So break those into those 3 different shapes, find the area of each of those, and then go from there. So the area of a triangle would be area equals 1/2 base times height. Always, always, always write that formula. I'm going to say it every time. Always write the formula. So that would be area equals 1/2. The base is 16. And the height we know right here is going to be 12 because that's the height of that square. So we know that those sides are equal. So we have 1/2 times 16 times 12. Okay, and then if we go over here and take 16 times 12, it will be 2, 1, 2 times 1 is 2, 3, 0 is a placeholder, 1 times 6, 1 times 1, which should give us 2, 3, 2. And then we're going to take that divided by 2 because we have to multiply it by 1/2. So I made a mistake here. This is supposed to be 1 and 1. Sorry about that. 1 times 1 is only 1. So it's actually 192. Okay, so 2 does not go into 1 equally. We don't want that there. So we're actually going to say that that's a 0, and then we're going to put it into 19. We can do that 9 times, which is 18. 9 minus 8 is 1. Bring down our 2 to make 12. 2 goes into 12 6 times, so that would be 96. 96 centimeters squared per turn. Okay. And then now we can look at the area of the square. So let's take the area of that square, which is area equals side squared, so area equals 12, because we have the 12 here. Area equals 12 squared, so we take 12 times 12. 2 times 2 is 4. 2 times 1 is 2. 0 to hold our place. 2 times 1 is 2. 1 times 1 is 1, as I just learned. 4 plus 0 is 4. 2 plus 2 is 4. Bring down our 1, so that should be 144 centimeters squared. And some of you may, from just your multiplication facts, you should know that 12 times 12 is 144. Some of you may not have remembered that, so we can just go ahead and solve it like that. And last but not least, let's look at our trapezoid. So to find the area of a trapezoid, you're going to write that formula. Area equals 1/2 times base 1 plus base 2 times height. So area equals 1/2 times base 1 we have from here is 12, because this is 12. And the other one up here is given, which is 9, and it does not matter which order you put those in. You could put 9 plus 12 or 12 plus 9, whichever way makes sense to you. And then right here our height is given, which is 6. So now we're going to solve that all out. So I have 1/2 times 9 plus 12, 9, 10, 11, 1, 21. So times 21 times 6. Okay, so let's go ahead and solve that one. So we're going to take 21 times 6, 126. So we have 1/2 times 126, or 126 divided by 2. 2 goes into 12 6 times, minus 12 equal, bring down the 6, goes in 3 times, so we should get 63. So 1/2 times 63. Then we have to take that. Oh, nope. Sorry, we were supposed to write 21 in here. So we already found the right here. So 1/2 times 21 times 6. Then we went ahead and did that next step. 21 times 6, which was 126. Then we had to divide that by 2, which is the same thing as multiplying it by the half. Sorry, which now got us to 63. Forgot to fill in the blanks as we went. Okay, so then we have that much information. Now we gotta look down here and find the total area. So we know we have the 96 from the triangle, so area equals 96 plus the area of the square was 144, plus the area of the trapezoid was 63. So we need to go over here and add those all together. Clear out all this work. Just rewind it back if you needed to see that again. So I'm going to put 144 first so I can line up my place values easier, plus 63 plus 96. Okay, so I'm going to do 6 plus 3 is 9, then add the 4 would be 13, 1, 6 and 4 is 10, 9 and 1 is 10, so that'd be 20. 1 plus 2 is 3, so we should get 303 centimeters squared for that area. So that kind of looks like a 6. It's actually a 0. There you go, 303 centimeters squared for the area of that total composite figure. Okay, this last example that we're going to work through is a little bit different than the ones we've done. So we're going to find the area of the shaded region. So as you can see, we have all that shaded except for this little box in here. That little box is not shaded. So we have to figure out what the area is without including that little box. So we're going to find the area of the rectangle, like the whole big rectangle. Here, we're going to find the area of this rectangle, and then we are going to find the area of this little square in here, and then we're going to subtract that back out. So let's just look first. Let's take the area of the rectangle. So area equals length times width. Something we're going to need to keep in mind is these inches. So 1 foot equals 12 inches. So we need to remember that when we are doing this because we have most of our measurements in inches, but this one right here is in feet. So this is the same thing as 12 inches. So we're just going to go ahead and convert that to inches so that we don't have to keep thinking of it in two different measurements. So area equals length, which is 12 inches. So 12 times width, which is going to be 6 right here. So 12 times 6 is 72. Then we're going to look at the area of that square, which is area equals side squared. So area equals 3 squared, which is the same thing as 3 times 3, which is 9. Now, to find the area of the figure without that shaded in area, we're going to take the area of the shaded region, which is 72. And we're going to subtract the area of the not shaded region, which is 9. So 72 minus 9, 6, 12, 3, bring down the 6, which would give us 63 inches squared. So the area of the shaded region is 63 inches squared.